Let us talk about passing multi-dimensional arrays as arguments to functions. Let's see this example. We have a 3 cross 2 matrix which is initialized as 10, 20, 30, 40, 50, 60. Then we call print function to print content of this matrix. In the print function, we have specified both the dimensions 3, 2. Then we are running nested loops. I equal to 0, I smaller than 3, I plus plus, then j equal to 0, j smaller than 2, j plus plus. And inside these nested loops, we are printing the matrix contents. So the output of this program is 10, 20, 30, 40, 50, 60. Now please pause this video and think of the problems with this code that we have written here. Now please pause this video and think of the problems with this implementation. The main problem with this implementation is the print function that we have written here. It works only for a 3 cross 2 matrix. What if we wish to write a general purpose print function or any other function that takes matrix as an argument? For example, transposing the matrix or anything which you want to do on the matrix. We want to call this function for different sized test cases. The matrix can be 4 cross 5 or 10 cross 20. But with this implementation, this function is supposed to receive only a 3 cross 2 matrix. How do we handle this problem? One way is to pass the number of rows as an argument. C++ allows us to have a matrix declared with first dimension being omitted. So I have to specify only the second dimension and I can omit the first dimension. Now this print function can take a matrix which has 2 columns and any number of rows, and it will work for all such matrices. We have passed the number of rows as an argument. Here also we receive this as an argument. We run a loop here. Earlier it was hard-coded for 3. Now it runs from 0 to m-1. So this code now works for any matrix with 2 columns. How do we ensure or how do we modify this function so that it works for any dimension? Unfortunately, there is no direct syntax in C++ for normal multi-dimensional arrays that allows you to specify row numbers and column numbers as separate parameters, because matrix declaration does not allow you to omit all dimensions. So in the problem videos of matrix, I'm assuming that there are global constant variables R and C which tell you the dimensions of this matrix, and I've used this kind of syntax in the problems just to keep the syntax really simple. Please note that this code also not a general purpose print function. It's going to work only for matrix of dimensions 3 cross 2. And these are constant global variables. We cannot change them for different test cases. But this code looks more readable because we are using R and C everywhere. And it makes sense, like R is the number of rows and C is the number of columns. Now we'll talk about other ways for handling this problem, where we can write a general purpose function which can work for matrix of any dimension. Let us talk about some C-style solutions to solve the problem. The first solution is double pointer. We use a pointer to a pointer to specify our 2-dimensional array, and then we pass number of rows and number of columns. Now this function can handle any matrix as long as this matrix or 2D array is represented using double pointer. You can pass any matrix, you can pass the number of rows and number of columns, and this function will print that matrix. How does this work? Now our matrix has to be allocated using double pointer or using a pointer to a pointer. What we do is we follow this memory structure. We have an array of pointers, and these individual pointers represent individual rows. So to dynamically allocate this array of pointers, we use a pointer to pointer, and individual pointers refer to individual rows of sizes 2. Once we have created an array of pointers, we run a loop, and inside this loop, we create dynamically allocated rows of fixed sizes. Now we traverse through these individual allocated rows, we assign some value to individual elements, and then we print these individual elements. So what are we doing here? We are assigning I here to the elements of ith row. So we are going to get the output as 0, 0, 1, 1 and 2, 2. This is what we will get as an output. The second solution is to use array of pointers. We create an array of pointers and size of this array is m, where m is user input. Then we can initialize this array by allocating memory for individual rows and then putting the values in the individual rows. So this is where we allocate memory for the ith row and then we traverse the ith row and we assign some value here. And again we are assigning 0, 0 to the elements at row 0 and 1, 1 to the elements at row 1 and 2, 2 to the elements at row 2. So we have a similar structure here. Instead of having a pointer to this memory location, we have this actually as an array. So this is an array where individual elements are pointers and these pointers point to individual rows. So again, we have a structure where we are passing number of rows and number of columns, and this works for any type of matrix, any dimension of matrix. It does not have to be some fixed dimension. Number of rows don't have to be fixed. Number of columns don't have to be fixed. You can write this generic code for print function and any other function that works on matrix, and you can pass the rows and columns as dimensions. Let us now see C++ vector-based solutions so that we can write general purpose matrix functions. Here is an example. We created an array of vectors. Then we are pushing elements to individual rows in this array. The number of elements in this array is equal to number of rows. So we traverse through all the rows and then we push elements to individual rows. In this example, I have pushed I to ith row. So first row is going to have all zeros. The second row is going to have all ones. The third row is going to have all twos. We can put any values according to our business requirements. Here is just an example. We are simply putting I. We can put 10 or any 20 or any fixed value. So this is how we create an array of vectors. And now we have written a print array function. It takes the number of rows as an argument and array as an argument and prints the matrix. Now the thing to note here in this function is we are not passing number of columns as an argument, because we can get number of columns by using array I.size. Individual array elements are individual vectors, individual objects, right? And we can get the size of individual objects by simply doing array I.size. Then we print the matrix. So here is one more method which is based on C++ STL to create general purpose functions that take a matrix as an argument and print the content of this matrix, or any other function which does any operation on the matrix, and it's a general purpose function. Let us now see the next method to write general purpose matrix functions. We are using a vector of vectors here. The number of elements in the main vector is going to be equal to number of rows. And then individual vectors are individual rows of this matrix. We create individual rows one by one. We push elements to them. And then we push the row vector to our main vector. Then we write the print function. And inside this print function, we are not passing the number of rows and number of columns as an argument, because arr.size will tell us how many rows are there, and arri.size will tell us how many columns we have in individual rows. Please note that we are passing it by reference to do optimizations, to avoid copying of this vector variable to this vector variable. The output of this program is 0, 0, 1, 1, 2, 2. Why? Because we have pushed value I into the ith row. So all elements at ith row have value I. We could put any value here according to our business requirement. Here we are putting 0 into the 0th row, 1 into 1th row, and 2 into 2th row. So that's why we are getting this output. So we have talked about different methods to make matrix passing better. There are some C-style methods which use double pointers or array of pointers. Then there are some C++ style methods which use vectors and array of vectors and vector of vectors. Please note that all the other methods that we have discussed, they look good. They give you other advantages as well. For example, in all the other methods that we talked about, we can create jagged arrays. A 2D array is called jagged array. if we have different number of items in individual rows. The vector-based methods give you other advantages as well. For example, when we are creating an array of vectors, then individual rows can have dynamic number of elements. You can dynamically remove and add elements and they automatically grow and shrink. In vector or vector methods, we can dynamically add and remove rows also. Number of rows are also dynamic in nature, allowed to be dynamic in nature. All these methods have these advantages, but they have a disadvantage as well. The disadvantage is individual rows are not stored at all contiguous locations. So they are slightly less cache friendly compared to the 2D native array. In that 2D native array method, we had all m cross n elements at one contiguous location. Here, individual rows are at contiguous locations, but these rows might be at different locations in memory. So certain advantages and certain disadvantages.